these are the notes that we did Thursday and Friday, depending on which class period you're in. So remember, if you go through, rewatch the video, and fill out the notes, it gives you the extra credit for opportunity, or the opportunity for extra credit. Definitely take the opportunity, especially if you missed a homework assignment. So I'm working on proving triangles similar. Now, if you remember back months ago, we had a section on proving triangles congruent. Now, if you're proving triangles congruent, we had like side, 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 angle, side, angle. We had all of those. So this is very closely related to proving triangles congruent. So for proving them similar, the three ways that we can use are angle, angle, side, 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 angle, side. So those are the three ways we can prove triangles similar. Now, the first two problems here are an example of angle, angle. So on this one, if you notice, I've got a 73 and a 73. So that angle matches that angle. Anytime I've got this bow tie figure eight, look, here's my bow tie figure eight. It's kind of like an hourglass. I know that these two angles inside here are vertical, so there's congruent. So I have one angle that matches, two angles that matches. So I can use angle, angle. So I know these are similar because of angle, angle. So this triangle is the same shape as this one. They are just different sizes. I need to go ahead and finish the similarity statement. So triangle GFE is similar. Notice the similar is just a little squiggly. This is the symbol for similar. If it was congruent, it would have an equal bar underneath. But similar is just the squiggly line. G matched up with G because that's the one in the middle. F matches up with K. And then L. So triangle GFE is similar to triangle GKL. So that's my first one. Now, number two. Again, I've got this bow tie figure eight going on. So I can mark my vertical angles congruent. I don't have any other numbers, but I do know that these two lines are parallel. That's what that little red arrow means. This is parallel to this. Because those are parallel, I know that angle E and angle K are going to match. Remember, these are alternate interior angles. Alternate interior. I can also mark, but I don't necessarily have to because I've already got my two angles, that F and L match. So now I have at least two angles that match. So angle, angle. So I can use angle, angle. Then I need to write my similarity statement. J, that's the one in the middle, so that's going to stay. K is going to match up with E, and then F. So J, E, F. So these first two, that's an example of angle, angle. The angle, angle ones are a little bit quicker and easier than the side, 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 which I'm going to do next. So let me go ahead and scroll down. Next two. Now these next two, all I have are sides. I've got all three sides here, all three sides here. So it looks like it's going to be a side, side, side. But if I'm going to use side, 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 I have to make sure my sides are actually proportional. So to do that, from this triangle here, I'm going to pick out the smallest number. So this is the smallest side. And that's going to compare with the smallest one on this one, which is the 50. 72, well, that's the next biggest. That's going to compare with the 60, which is the next biggest on this one. And then 84, 70. So I've got three different ratios that I can use to compare the sides of the triangle to see if this triangle is in fact proportional. Because I don't know they're similar unless they're proportional. So now, I'm going to use my calculator. 60 divided by 50, I get 1.2. 72 divided by 60, I get 1.2. 84 divided by 70, I get 1.2. So every single one of these fractions give me the same value. So this triangle is proportional. So I can say that I use side, side, side. Now, if you're using side, 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 I have to see this work because you've got to prove that it was actually proportional. Now I'm going to go ahead and write the congruence or the similarity statement. Now, this is a little bit tricky because you don't have any angles to go from. So E was between the small and the big. So down here, the E between the small and the big, that's going to be the J. So E is going to match up with J. So that's where I'm going to start. F, that's between the medium and the big, or the small and the medium. So between the small and the medium, that's going to be K. So I'll finish it up with L. So JKL. That's my similarity statement. And like I said, that's a little bit tricky just because you don't really have any angles to go from. So that's why I marked my triangle, because it was a little bit easier to go from. So that's the answer there. Now the next one, pretty much the same idea. I've got my three sides. So small side compared to small side. Medium side compared to medium side. Big side compared to big side. There's my three sides. There's my three sides. You've got to check them. 30 divided by 18, I get 1.6. And it turns out that all of these give you 1.6. So therefore, yes, it worked. It's proportional. So because it's proportional, I can say it's side, side, side. And you'll find out later in these notes that sometimes it'll look like it's working, but one of these numbers won't be the same, so it doesn't work. So that's why you've got to check it. Now go ahead and do the similarity statement. F, G, H. I'm going to go ahead and mark this one. F is between the 30 and the 40, which are the smallest two. So that means if I come down here, these are the smallest two. It matches up with R. G is between the middle and the big. So between the middle and the big is going to be S, and then finish up with T. So RST. And I think the side, side, sides are the trickiest ones to get this similarity statement because you've got to make sure these are in the right order. It has to be in the same order as this one. So those are two examples of side, side, side. Let me go ahead and scroll to the next two. Five, six. Now 5, 6, again, I've got this bow tie going on. So because I've got this bow tie figure 8, I can mark my vertical angles. So I have an angle, but I don't have any other angles. But I do have a couple sides. 9 is the smallest on this one. 27 is the smallest on this one. So I'm comparing 9 with the 27, 12 and the 36. Well, if I divide 9 divided by 27, I get 0.3 repeating. 12 divided by 36, I get 0.3 repeating. So yes, they are equivalent fractions. They are the same, 0.3. So now I can go ahead and say that it's side angle side. Now this one I think is a lot easier because I've got an angle to at least go from. So F matches up with F. I went to G, so you're going to go to T. So FTU. That's my similarity statement. And like I said, it's got to be in the correct order. 6, pretty much the same thing. 84's match. Well, it turns out that these two triangles, that's an isosceles triangle. So 24 over 15 is just going to be the same thing on both. So I don't even have to divide this one because of course 24 over 15 equals 24 over 15. So it's a side angle side. P matched up with S. Now it doesn't even look like it got turned. So they did PQR, so we're going to do STU. So STU. There's my similarity statement, STU. So those are 2 examples of side, angle, side. So we had angle, angle, side, 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 angle, side. Now the rest of these are just more examples all mixed up, and some of them don't work. So I want to also show you some things that don't work. So let me go ahead and move again. So 7A, all I know were sides. So if it's going to work, it's going to have to work with side, side, side. This is definitely the longest ones because you've got to check it. So 12 goes with the 18. 18 goes with the 27. 20 goes with the 30. So there's my 3 sides that I'm comparing. When I go to divide those, 12 divided by 18, I get 0.6 repeating. 18 divided by 27, 0.6 repeating. 20 divided by 30, 0.6 repeating. So yes, they're all the same. So this is another one that works. So I'm using side, side, side. S, T, U. S is between the biggest and the middle. So between the biggest and the middle, I'm going to mark the B. T is between the small and the middle. So between the small and the middle, I'm going to mark the C. So B, C, D. B, C, D. That's my similarity statement. And like I said, you've got to get those in the right order. Number 8. Well, it looks a lot like this one. So I got to check it. 88 goes over 40. Those are the smallest. 110 goes over 50. And then 132 goes over 61. So there's my free fractions. So when I go to divide this, 88 divided by 40, I got 2.2, exactly 2.2. 110 divided by 50, I got exactly 2.2. 132 divided by 61, I got this big long decimal, 2.163, blah, 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 blah. Well, these have to be exactly the same, not rounded the same, but exactly the same. So since this one, I would have had to round to get this, it's not going to work. So this is an example of one that doesn't work. So this is not similar. Not similar. It does not work. So this is another example of side, side, side that did work. All of these were identical. This is one that didn't work. 2 of them matched, but the third one didn't. And if any of them doesn't match, it doesn't work. If it doesn't work, don't do the similarity statement because it didn't work. Next two. Nine and 10. Well, I have an angle. And that's my only angle. So if it's going to work, it's going to work by side, angle, side. So I've got my 6. That's the smallest of these two numbers. I've got my 28. That's the smallest of these two. And then 942. There's my ratios. Go ahead and check them. 6 divided by 28. I get 0.214, and it's going to kind of keep going. 9 divided by 42, 0.214, and it keeps going, and I get the exact same value. As you can see, it's the exact same number for both. Identical. I didn't round it. So because it was the exact same value, it worked. So it's a side, angle, side. Q matches up with J. That's an easy one. R is the bigger of these two sides. So J, I got to go to K. Because it's the bigger of the 6 and the 9. And then L. So JKL. Number 10. Number 10, I probably should put something else here because it's another side, side, side. It's a pretty easy one. 80 goes with 80. Well, let's start smaller. 60 goes with 6. 70 goes with 7, 80 goes with 8. Yeah, all of them give you a 10. So yes, it's going to work. So side, side, side. D is between the 60 and the 70. So therefore, between the 6 and the 7 is K. E is between the 60 and the 80. So I got to go between the 6 and the 8, which is L. And then finally M. So KLM. That's my ratio. That's my similarity statement. So this is an example of a side angle side that works again. This is another example of a side, side, side that works again. So that's 9 and 10. Last page. 6 to go. I give you no numbers whatsoever. The only thing I gave you was markings. Yes, these two would be the same because of that bow tie figure 8, but this doesn't match either one of these two. And this would have had to match one of those two, so it doesn't work. So that's it. I didn't have to really do anything at all other than just look at the picture. It didn't work. Because it doesn't work, don't finish the similarity statement. Number 12. Now 12, the 54 does match the 54. Those are the same. Got my bow tie going on, so mark those verticals. So that's good. So C was in the middle. D was the 54, so I'm going to go to the V, then W. And I used angle, angle. So this is an example of an angle, angle, it doesn't work. This is another example of an angle, angle, it does work. So those are two more angle, angle problems. Angle, angle. And like I said, the angle, angle ones are a lot quicker because you don't have to check it. You just have to look at it. 13 is a little bit trickier. 13, I've got this triangle here. And then I've got another one, they're kind of stacked on top of each other. I've got this triangle here. So there's my two triangles. I've got this smaller one and this bigger one. Now this angle M are the same for both. Both of them use this corner. And they both have an 84. So therefore, I can use angle, angle. Because two angles match. This one was the exact same angle, and these two are the same number. So M goes with M, because that's where they're connected. L means I'm going to go to G, then F. There's my similarity statement. That's my similarity. MGF. Now 14, again, these get stacked. I've got this one, and I've got this one. But right away, I see that 44 isn't the same thing as 47, so it doesn't work. This one was the same. This one wasn't. So it's just not similar. It doesn't work. And again, if it's not similar, don't write the similarity statement because it didn't work. Last two. This one's probably the trickiest of the bunch. Again, I've got this little triangle here, and then I have another triangle here. So here's my two triangles. Now, S is the same for both. So it looks like a side angle side because I have an angle with sides on either side. So I've got to check my sides. So my sides, I'm going to compare the 65 and the 39. The 55, and here's the tricky part. I've got a 22 here, but I'm not actually using the 22 over here. The 22 is going to help me find 33 here because I need the red triangle. So 55, subtract 22. If I chop this piece off, I get 33. So I need a 33 there. That's the tricky part about that. So now I can go ahead and go 65 divided by 39. I get 1.6 repeating. 55 divided by 33, I get 1.6 repeating. They're the exact same ratio, so they're proportional. So I'm using side angle side. S goes with S. T goes with E. And then F. So SEF. Last one. I've got my bow tie going on. Anytime you've got this bow tie figure 8, mark those verticals. Mark those verticals. We've used vertical angles probably 200 times. Out of these two, 17 is small. Out of these two, 45 is small. Then 2150. 17 divided by 45, I get 0.37 repeating. 21 divided by 50, I get 0.42. They're not the same number. Yes, if I tried to round, I could get them to round the same, but do not round. They have to be identical down here, the exact same, without any rounding at all. So since they didn't match, my last one here was not similar. Not similar. So these go with the homework, proving triangles similar homework. This homework isn't due till Wednesday. I'm trying to give everybody a little bit of extra time to get things done. Plus, that way, if you have struggles on it, you can come in. I was going to say during office hours, but there is no office hours Wednesday because of Martin Luther King. So this isn't due till Wednesday. This is due Wednesday night. If you have any questions, send me an email in the afternoons. I can give you a hand. So fill out your notes, get your extra credit. Bye, guys.